In this video, I'm going to show you how to use hashes to store your passwords. Now, the first thing to just understand is what a hash function actually is and how it relates to passwords. Now, a hash function is basically it's a function that takes usually a string or a number or a phrase or something, and it generates a unique number or value associated with that particular string. Now, in the case of passwords, the way things work is when you create a user, you will enter a password, and that password will then get hashed, which then creates a unique number. That unique number is then stored, which is why companies who store your passwords don't know what your password is. They only know what the hash is. And the thing that's really important about hash, or a good hash function, is that there is absolutely no way you can get from this number to this password. The reason for that is because the function is what's called a one-way function. And generally speaking, you lose bits of data as part of that function. And I'm going to show you a function in a minute, and you can see that parts of it get lost. So there's absolutely no way of getting from this number to your password. So how does it work? Well, we store the hashed password, but when we come back to actually try and log in, we enter our password here, it gets hashed, and we generate the number. And then we compare that number with the one that has been stored, and obviously if those two numbers are the same, then the password must have been entered correctly, and therefore we can be allowed inside. So that's kind of the principle of how password hashing works. Very simple idea. So how do we get these passwords? Right, well the first thing to do is you need to do a bit of Googling. Okay, and I just went online and found this thing. I think, what did I type? Oh, okay. The simple hash algorithm. There's loads of them. And I found this, and I'll put the link to this. This is quite a good one. Put the link to it. And it's talking a little bit about the big O, and it gives a little bit of a background. And if you're into mathematics, here you go. Now, obviously to me, this is all just mumbo jumbo, although I'm sure I could break it down. Here's a string, that's the first one plus the second one. Anyway, and so you're multiplying by some multiplier, and then summing it all up at the end. And this is the bit here where we're losing some information because we're taking the modulus of all of this. And, oh, hang on, I've just got to stop for a second. I'm back. It's the modulus function that is actually causing us to lose the data. So you can't reverse a mod. And obviously you don't know what the starting number was from the mod. So if you take for example, if you do say 10 mod 2, you get 0. Well, you also get 0 from 8 mod 2. So there's no way you can get to 8 or 2 or 10 from doing that modulus. Anyway, they give the function here. Now this is written in C, but you'll notice that C is very similar to C#. Long is basically just a big number. Well, we can just use int. Int in C#, I think, is 64 bits long. Long in C is 64 bits, so you can use an int. Well, it's a string. Don't worry about the fact that it's const reference. Just a string will do. And then the thing that's kind of interesting here, in string, so this is a for each function here, but in C, you can do things like this. You can interchangeably use letters and characters. Characters and numbers, you can kind of treat them as if they're the same thing. It's basically a char is just an 8-bit number, and the fact that it happens to represent an actual character, C doesn't really care. C#'s a little bit more picky than that, and so what we actually need to do, I've got the function here, we need to encode it and use something called a byte. Okay, so they differentiate the difference between a char, as in something that has a character, and a byte, which is just 8 bits of memory, which could have a character, and use this function here, encoding.ascii.getBytes. To get that to work, you need to use system.text. Okay. So here we go. Here's the algorithm. So you define a p, you define an m, which is a big number plus 9. Don't ask me why. You have a cache value, and you have some pointer to, I don't know, whatever it is. And then for each character in the string, here we go. Work out the hash value, which is kind of like that. Okay, and then you do something to the p pow, and then eventually you return the hash value. And look, there's our little modulus. Okay. Now I've just copied this, so you know it's up to you. Lots of different hash things. Another one that I found was this one here. This has lots of different variants. Again, you know how to have things. You'll notice they often use shifting in hash functions. Anyway, I'm not going to go into that. I had a little go, and let's just see it work. So I tried a password. So if you use the password with a capital H for hello there, you get this number here. It's a negative number, doesn't really matter. And so what I'm going to do is basically get the person to enter the password. If their password is the same as the hash, then obviously we say welcome. If it's different, we say denied. So let's just run it. Let's see what happens. So here we go. Quick. It's the first time I've run it this evening, so it might be a bit slow. Right, so if I type hello there, like that, that has said welcome because the hash of hello there is the one that is this here. However, if I change it by one letter, and this is case sensitive, which is quite nice. If I go hello there, like that, we're denied. It's not going to let us in because it generates a different hash. And that's as it should be. That's absolutely. And let's try and see if it's lowercase. If that works, hello there, denied. So we have to get the password right. So top marks to add a hash function, and in my opinion, this is something you can implement probably in about half an hour or so. Good luck.